So the idea here, as we have just started the recording, in order to do the Multus practice and also understand Multus from the beginning, we decided to do it on the machine directly, and I was facing some issues with GKE. It seems they do have their own version of Multus, and they do allow you to do attach multiple interfaces to the pods. But we would like to do it in our way. So instead of relying on GKE, what we did is we just launched one virtual machine on in Google Cloud. Yeah, that's the virtual machine, and for it we use Ubuntu operating system. Any would do, but latest Ubuntu would fly. So once we are done with that, what we did is we install kind, kubectl, editor vim. It's not it. You might have it already by default, but in my case it wasn't there. Then we installed Docker, and finally we copied our config for kind cluster from the Git repo, and we launch our first cluster. That's what we have done until now. Now, from here, we are gonna start looking into Multus. Yeah. So kubectl get pods. I'm just checking if control plane looks okay, which is fine. I can clearly see that all of the control services are fine. Yeah. So let us start with Multus, understanding Multus now. Now in Multus, you have a very first. Let us start with a concept. Yeah. So what essentially we said is what Multus is. It would enable more than one interface on your machine. So if this is your pod, you have ETH0 by default from Kubernetes, and that's the maximum Kubernetes can do for you. But you have a lot of use cases where you need multiple interfaces. Yeah, for example, traffic separation, traffic isolation, or let's say network customization, any kind of network function which process traffic, need multiple interfaces. So your default interface will work. That's also called networking, pod network, right? Pod networking in our case. So with pod networking, you can interact within the cluster. Yeah, for example, other services. Let's say it can be used for management. It can also be used for some of the um, you know less important tasks. For example, backup or some kind of, let's say, tasks which are not user facing or not serving the actual traffic. But then your other interfaces which are also needed to be very performant. So you would end up using SRIV or DPTK. These are keywords which we are going to discuss, but for now understand that you need some performance here, and this generally would integrate with your physical networking underlay. So this will have a peering with, let's say, switch or a router, and the gateway would be on the router instead of on the machine. So essentially you need multiple network to be connected to the same pod, and that is enabled by Multus. Yeah. So in Multus, it works like a razor card extension of it. You have a default one, CNI. From there you get ETH0. So first interface, please ignore the loopback, which is itself. So we are ignoring that. Your first interface would be ETH0, and then net zero onward, you will have multiple other interfaces based on how many network you connect to it. Yeah, those will come from your another special CNI, right? That would be the next thing. And we also said multus is a Latin word which also means multiple. So simply in this case, when you see multus, it means you just need to understand that it is just enabler for having more than one interface on the pod, nothing more. It's a piece of software. It is also called, or let's say it's also type of CRD. CRD is custom resource definition. CRD is nothing but an extension of your Kubernetes. Whatever functionality you don't have in Kubernetes, you would like to introduce something to Kubernetes, you can use this CRD, let's say, spec to build your own CRD, write the functionality and integrate it with Kubernetes. Multus is that type of resource. So it is not part of Kubernetes, it is add-on. That's why it is called plugin. Yeah. most of the plugins would use CRDs to maintain their data, to store their functionality in Kubernetes, and also to have references there. So that's the idea. Now coming back to our lab, we need to understand two basic concepts. One is default network, right? So the default network is nothing but let us try to maybe create this, yeah, Multus dot md. So we need to have, let's say, the key concept is what? It's a default network, and that's the default network. That's my first interface, right? On the container. So I'll call it's a first interface on the container, on the pod, yeah, because pod share the networking with all the containers, right? So it's a first interface, and it provides the functionality. What it provides me pod to pod communication, right? That's what the first interface would do. And then you have these CRDs, right? That's also in our cases Multus, right? That's gonna provide me net zero interface. Okay, net zero onward. So if I attach two, it will be net zero, net one. Yeah. Um, and this is nothing but a Kubernetes API extension. Yeah, API extension. Um, which will be used to maintain the multus, let's say multus information, yeah. So that's the CRD. So you have two type of network. The first one is default one, and the CRD, also called multus, that the interface may be, not maybe, it will be net zero or net one, and so on. Now, when you do Multus, you need to understand there are phases. Like you need to understand it in phases. Yeah. So as it's piece of software, or let's say, it is first of all you will install it, right? And then once it is installed, then you will use it. So you will deploy this inside Cube system. Yeah. So the installation of Multus would happen under Cube system. Uh, Once it is deployed as a data set, as a let's say daemon, once it is deployed, then what you will be doing is you will create something called network attached definition. Network. So it's like actually network attachment definition. Yeah. So definition. This is nothing but a network. You can call it as a network. So you install the software Multus. Yeah. So install Multus. Then you create this NAD. It's N network attachment definition. It's also NAD, right? It in short. Yeah, you can also call it NAD, but this is like our shortcut. It's not. I mean, it is in Kubernetes. You need to get it network. You need to say network attachment definition. For us, it's NAD. So you do that. You define the network, how you want to do it, and then what? Once it is defined, then you launch a pod, and then you use it. So let's say use the network, but how do you use it? Network. So how do you use it? You would launch a pod, right? So attached to the pod, right? That's the thing. Attached to the pod. So we are gonna do this all of three. One is install Multus, create network attachment definition, and then use it. So these are the three steps we need to do. And this is, I think, same for any kind of software, right? So when you install something, in this case, Multus, once it is installed, then you define or do you configure that. That's our network definition. You can also call it network in the plain language. It would also have some other information, let's say, but for us, let's call it network attachment definition. Then you use the network once it is ready. Yeah. Now, there is also one interim, let's say, step, uh, intermediate step, which is not necessary. to do. But let's say you install something, but whatever CNI you are using, that CNI drivers need to be present on the Kubernetes node. Otherwise, that won't work, right? So we have something called driver installation, right? Driver installation. So you install the Multus, then you install the driver, the this CRD net zero. In order to have this net zero, you need to have some kind of drivers, right? For that particular device, whatever device you're using or type of network you're using, that has to have that. Obviously, that would be supported by some kind of driver, and that's what you need. So you need to make sure your drivers are installed. Not necessarily that you need to install it every time, but you just need to make sure that they are there. If not, then you would install them, and then you will move to the next step. Next step, yeah, that is network creation. Let us do that now. For now, okay, maybe we can improve this a little bit. So where do I install it? I'll install it in Cube system namespace. Yeah, this is more related to, let's say, system. So I'll install it in Cube system namespace. Yes. So that's what I'm gonna do now. Okay. So we are here, Multus. Now let us try to do that. So here I have this is a file which we are gonna use to install the Multus. Now this is, as you can see, it's from GitHub. Yeah. So it's a YAML file. So it's a manifest, all right? In this case, you can clearly see that it's a custom resource definition. Yeah, it is custom functionality return in the manifest in the with the spec. Obviously, there is a structure, and you need to follow the let's say the guidance which you have from Kubernetes. For an example, you need to provide this short name, and this will be visible. So you can also, whenever you want to interact with it, you can say kubectl get net hyphen attach hyphen def, and you should be able to get the definition of it, right? So this is all as per Kubernetes guidelines. So you are extending the functionality of it just by defining the custom resource definition. Now there are some other things which are needed in order to make this, in order to support the functionality of this. And this is cluster role. So you are creating some roles, and you are binding these roles with cluster. So so that you can give, let's say, more power to this software. It can create, patch, and update resources. So you are creating a role that would can create, patch, and update the resources, and then you can see what resources it can work on. It can work on pod, right? And these are the commands which it can do. So this is a role essentially, and this role will be, it's a binding. So you are saying, okay, bind this role to the cluster, and will at cluster level, and give this access to Multus. So Multus, and then Multus would use service account to gain this power, right? So all of these resources are needed for Multus to let's say to support the functionality. And that's a deployment. We have seen this. This is not a deployment, it's a daemon set. So daemon set would spawn let's say certain number of replicas of your Multus, so uh, per node one. Yeah, that's. Now we are not gonna go in deep because you're not. I mean, it's not. We can essentially, but we can do it, but it's not needed. It is complex, and I don't think you will be able to go to this level. When you will be part of Telco Cloud team. You can, by the way. Yeah? So this is just a matter of deciding how deep you want to go in this. For now, I think to abstract unnecessary complexities, we need to understand that this is our manifest, which will deploy our Melter software. Obviously, there is a software itself. That image will be pulled from somewhere, from the repo, and there is a config associated with it, right, with the software. So that's what we are gonna do now. So I'm just taking this and I'm saying, or I'm issuing a command kubectl. I'll simply apply this -f and I'll apply this manifest against our cluster. And I can now see that the network attachment definition is created. It's a customer resource. Yeah, I can also see Multus, a cluster role, cluster binding, service account. The power of this two will be used using this service account. A config map is to store the configuration of your Multus, and the deployment model, a daemon set. Yeah, to deploy Multus on the on every node of your cluster. Now I would like to get the Multus, and I'd like to see its health. So kubectl get pod -a, and I would like to grep. So give me all the pod in the cluster. A is all namespaces, not one, all namespaces, and then grep for Multus. Okay, I can see 56 seconds ago there are two pods, Multus, Cube Multus DS is daemon set, spawn on two machines. One is your worker and a control, right? That's the idea. And they are working fine. I can clearly see it's working fine. So now the Multus daemon set would, what it would do is it will it will run a pod, yeah, and it will copy a binary file into opt-cni bin on the worker node, right? So in our case, the worker node, as we know, it's a Docker container, right? It's a worker node. So I can, when I do Docker PS, I can see two nodes, right? Two Docker. Those are my worker nodes. So I know this worker because it is tagged in that way. So I'll just simply connect to it. Docker -it exec hyphen and then Docker name, and I'll say sh. So okay, bash. No, Docker is this, maybe give me a moment. I'm trying to connect to this Docker exec hyphen it bash. So I think I switch this sequence. Now I am inside this Docker. Now I should have a directory called opt cni and bin. Now inside it, it will create, yeah, this is latest one, right? It will copy the necessary files, yeah. It will copy the Multus binary on each node. Now in our cluster, we just have one worker, but on each node, it will copy the binary file. That's the work of this pod, Multus pod, yeah. It will also create a config file for the Multus. So when you don't have Multus, you have the default config file, which is 10 kindnet.config list. So this is your pod network. Yeah, it might be different name in your case because it's not a kind, but this is essentially your pod network. So it will give you the same thing here. When I say same thing, meaning it will follow the same spec. Whenever Kubernetes work with any kind of config, the structure is always same. You will see the same structure for Multus, but in this case it is P2P, yeah, in your default, and then you have your default range, MTU and other things, right? This is the default file which provides you pod-to-pod networking. So our default network comes from this file, which is created few hours ago, right? So this was like 356, but then we install Multus and then 411, we have this multus.conf. Yeah. So multus.conf is a multus config file. Yeah. So I'm not in that directory, that's why. You can see similar thing. It is just that you don't have it in this fashion. The information is the same. Yeah, you have CNI version, you have log, you have name, multus, and other things. It is similar. It is gonna refer. This is not the exact definition, but it is gonna refer for the definition. If it is gonna get the definition. It is because it's a plugin, so you don't see the exact details, which you will see in network attachment definition. All of these details you will see in network attachment definition, which we haven't created yet. But this is a plugin, right? It's a multi shim that will connect that network attachment definition, and then you'll be able to use the Multus. So what we have done until now is, okay, guys, where were we that time? Multus.empty markdown, is it? Hmm, our file was in default directory, but oh, okay, yeah. So sorry about it. I was on Docker, inside the Docker, and I missed it. So here, our Multus is here basically. So what I'm saying is, um, we have installed the Multus now, yeah, uh, and we have checked it. Mm, we have checked that it has created OPT CNI bin. So let's say here, yeah. So here, it has created, or not created, copied. So let's say install. I'll say install a config file, or a binary file. It's a binary actually. Binary under opt cni bin. Yeah. And then the next thing it does is it also installed config under etc cni net.d. Yeah. And the name of the file was 00multus.conf. Yeah. So these three things are now are completed. Yeah, and there is also a authentication that the service account, right? That details it will copy to the Multus directory, but it's not important for us, so we will not save it here. Yeah, we'll not consider it now. As the Multus is now installed, what we can do is we can now create our network attachment definition, or maybe, yeah, let's create our network attachment definition. Now in order to create a network attachment definition, we are gonna use the same config, right? We said we'll be using the similar config. Let us do that. I'm not gonna um, I'll simply say create, and then just create mac vlan -conf .yaml. So this one, I'll just say NAD, right? So it's a network attachment definition. So I'm creating it, and obviously I'm copying it from the repo. Yeah, so that we don't have to type this much, but we will explain it. So in this case, you can see network attachment definition is a kind. So this is a NAD kind of resource. The name of it is macVlan conf. And if you recall the config, this is the exact config which we have seen. Just the type is different, right? So CNI version is this. Type is macVlan. This is the type we are using. It can also be SRIV. It can also be bridge. It can also be, so here you need to recall your Docker networking type. all networking types are supported. We can also, or we will also see SRIB and DPDK. But in this case, we are using Mac VLAN and the master interface is EDS0. This is important. So Mac VLAN interface, you are using this Mac VLAN, but what is the master? And this master has to be on the worker. So you will have to make sure that whatever your master you are mentioning here, that is available on that particular worker. If the interface, the physical interface on the worker is different, its name is different, then this will fail, right? This will fail. Okay, so we will verify if the name is ETL0. If not, then we will correct it here and again apply it. Now you have mode, that's bridge. We are gonna bridge it with the existing interface, and you have IPAM. That's a local IPAM. You are just saying subnet is this, range is start from 9.240 to 9.250, and the default gateway is this one, and whatever route or whatever network packet I have, I'm pushing it to default gateway by default. That's the idea. So now this is created, the definition is created, and the definition again is this one, right? So here, if you recall, the network attachment definition, what we can do is we can apply this network attachment definition now. But let us try to open our Multus. Let us try to open our, why it's not working again. Okay, somebody had joined. Let me try to, yeah, yeah. So in this case, let's say your network attachment definition here, we will say it's defined, right? So now it is defined, NAD. So network attach def is defined. The next thing we want to do is we want to apply this, right? Apply is not done yet, right? So why I would we can also apply, but let us try to see if we have driver installed, because that was one of the step, right? So the driver is what? Um, the driver is basically your Mac VLAN, right? So Mac VLAN is a driver. Now, do we have that driver available in your OPT bin, OPT CNI bin? Let us check it. Let us check. So Docker PS, we are again gonna go to our worker node, Docker exec-it and sh will give us the shell from this, yeah, and then we will list what opt cni bin, and these are your drivers, but we can clearly see Mac VLAN is not there. Now that's why we need to install Mac VLAN. So we have a command, and I'm gonna provide it to you. This is basically, again, it is downloading the Mac VLAN from your Git. This is a driver, Mac VLAN driver, yeah. So it's downloading it. That's the idea. So I'm gonna download it here and then install it in the directory, yeah. So it's one command. You can simply copy it and post it. It's gonna do that. And now we will again see if we now have opt cni bin. Now we have Mac VLAN. Just now we installed it, right? Uh, we just downloaded it from GitHub, then we untar it, and then we copy it to our opt bin. That's the only thing we did. So coming back to our main machine now, let's say mul, mul sorry, Multus. Multus, now what we have done here is we have installed the drivers. Which one? Mac VLAN. And hence now we should be able to attach this config, right? So I'll say kubectl create -f, and I will simply give my network attachment definition manifest, and you can see it's created. So if I now try to do it, kubectl get or kubectl resources. No, kubectl, what is this? Get resources. Is it? No, 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 no. My bad. Kubectl get network. Network attach def. Oh, no, I think I am not giving it correct name. Let me just get the full name. So I'm just trying to. Okay, so kubectl get network attachment. Hmm. Kubectl get all -m I Mac VLAN, and then this command I was missing. I'm so sorry for this, guys. So it's kubectl API resources, and this is where I'll say network attach, and that's the net attach def. That is the thing. So kubectl get net attach def, and this one we have created Mac VLAN conf, right? This is the one. So if I say kubectl describe net attach def, net attach def, and then this one. Yeah, this is what we have applied if you see. So our driver type is your Mac VLAN, ETS0 is our master, and we haven't verified it. So let us try to do that. We will log into our machine and try to see if the Ethernet is ETS0, otherwise it will fail, right? So docker exec-it and then bash and IP address show. And we can see it's ETS0. Yeah, forget about this because this is just showing you more information of where it is connected, if you recall the last session. So for now, ETS0 is there and it will work, we know that. So exit and we are back again. So now we have also verified, we have done the installation. We have also verified the applied. It's already so apply done. And then verify the master interface. That's also done, right, on workers, I would say, because you have multiple workers. In this case, it's just one, but you will have multiple. And now the next thing is use this network. And how do you use it? By attaching the pod. But can we just, yeah, why not? Let us try to launch two pods and see if those are working. Or let's say start with one and see if that is working. So what I'm gonna do now is I have the pod definition. I will just to save some time, will create vim nad or let's say mac vlan underscore pod dot yaml. So we'll install it here, and this is nothing more than a pod definition, right? It's just simply a pod definition. It's a pod annotation. The most important thing here in the pod definition is this one. How do you attach your new network to your pod? That's the annotation. Annotation, this one tells Kubernetes that whenever you launch this pod, get this, get the networking from network which Mac VLAN conf. So from network attachment definition, the name of it is Mac VLAN conf. So this is most important. This is the most important step to have or to add annotation. And you can see this blue, right, until this one. This is a standard thing, so you will see it everywhere. The name, this is your network attachment definition name, right? So you will just add it here. That's it. If my network attachment name is srivconf, I'll add it srivconf, or sriv network, I'll add it as sriv network here. So the annotation, this is one of the most important thing. So we add it here. We'll say, in order to use it, first of all, what is needed? What we did define pod. Yeah, pod YAML, I'll call it that way. And then what we need to do is to add annotation. Add annotation. But under annotation, what we need to do? Add annotation. I will say network name or NAD name, right? That's the idea. So we have done that. In the pod, definition, we have added annotation, and this is our network attachment definition. And this is our spec. So we have a container called netshoot pod. Our netshoot famous image that has a lot of tools, and that's why we are launching it. So simple. We will now launch it. kubectl apply -f macVLAN pod YAML. I'll create alias. Alias is nothing but you can define a shortcut. So I am a little bit lazy. kubectl. I'll simply say kubectl k. So I'll say k get pod. Okay. You can get more lazier than this. You can simply say alias k get pod. So kgp is equal to kuber. Yeah. So you can define it this way. So you can say kubectl get pods. Yeah, you can also do that. So KGP will get you pods. Yeah, KGP will get you pod. In this case, now I have a pod and it's working fine. What I need to do now is I'll have to log in into it to check. I will have to log in into it to check if I have interface, the new interface attached to it. So I am logged in. I'm just trying to go to the pod and I landed in the pod. The command is kubectl execc-it, the name of my pod, and then hyphen hyphen. After this hyphen hyphen, you will initiate a command. Sh is a shell, so it will open a shell for me from that pod. So I am inside pod and connected to the pod. Now I'll simply say IP address show, IPAS, IP address show, and I can now see net 1. So net 1 is the interface, new interface. Net 1 is a new interface which is added from our network attachment definition, right? So you can see our range was starting from 240. This is the first IP of it, right? That's coming from your network attachment definition. And ETH0 is the default network, right? Now let us do one more thing. Now let us try to exit from here. What we are going to do now, or maybe let's come back to what has been done until now. So here, what we have done is we have also launched our pod, right? Pod. So deploy pod. Yeah. And then we check, check, check interfaces. Yeah. But we haven't done the checking of our network, if it is working fine or not. For now, it looks okay. Yeah. For now, it looks okay. So let us try to do one more thing. Let us try to launch one more pod. Now this pod we will launch as pod 2. Yeah. So we'll say macVLAN pod 2 and its name we'll change it to pod 2. Yeah. Nothing changes. Everything else is same. Our annotations are there. Yes. So we are launching a new pod. kubectl create hyphen f and then we'll give macVLAN pod 2 and kubectl get pod kgp. If you recall, this is needed for your exam to save the time. Yeah, if you run your think about it, it's simple math. If you run kubectl get pod 1,000 times, you will save 1,000 seconds. That's the idea. So you have your new pod ready, right? So let's say kubectl exec execute, and IT is interactive terminal, attach the interactive terminal to pod, Macmillan pod 2 hyphen hyphen, and the command is either bash or sh. Both are shell, they will open a shell for you. IP address show is a command, or you can also say IPAS, that's also IP address show shortcut. So now you can see net1 available on port 2 also. And then the IP assigned here by local IPAM is 172.17.9.241, and the previous one was 240. I can see it, but is it working? And this is what I wanted to test from this container, right? From this new pod. So I'll ping, and I can clearly see that 240 is responding. So the networking is in place. This networking, this network is working for us. Both pod can reach to each other on this network. And the default one, we all know it already is working, right? So we don't even have to test that. But this one is working fine. Yeah. So what we have done now is this one. So we checked interfaces. Yeah. So we deploy second pod. Yeah. And now what we have done is we tested networking using ping command, right? Worked fine. And that's it. That's the Multus hands-on, I would say. Yeah. What we can do is, just to show you, we can also initiate the same command from pod 2. So we can do kubectl exec-it, and then instead of running or attaching to the network, we can simply say, I would like to ping, but 241, because I'm pinging from where? I'm pinging from this one. Its IP is 240. I'm pinging from this one to this one, 241. So this is my one, right? So this one, 240, I'm pinging to 41, and it's working fine. So the networking is working fine. That's the that's the idea. Now let us try to do something more. Kubectl get pods and do wide -o wide. And in this case, you will be surprised that when you do this, um, maybe you are expecting that you will see both IPs, but it is just showing you the default IP address coming from your default CNI. And that's absolutely normal. Yeah, that is absolutely normal. Yeah. So here, when you do the events, this is where you will see your ETS0 is coming from your KiNet, and your net1 is from your default Macmillan conf net type, right? So you need to understand that whenever you want to see how many interfaces, you can either go and try to get that information from event, or you can also try to do this kubectl get or kubectl describe, and then you will say describe pod. You will describe the pod. This is where also you will see events. So in the events you can clearly see interfaces and the flow. Yeah. So the flow is simple, and this is also a good idea to understand how things work. So when we ask Kubernetes to launch a pod, it basically handed over that information to scheduler, and scheduler is a default scheduler. And you can also guess that you can have a customized scheduler too, but we are using default one, which is coming from Kubernetes, that assigned a node, right? Assigned a node for default. Default is a namespace. This is your pod. Two, this pod is assigned to which node? Kind worker. This is our first worker node. And then next what happened? Added an interface. So it contacted CNI, added one interface that's from default, second interface that's from our network. Then it actually pulled image from the repository, from the registry. Once it is pulled, it says it is now pulled and cached. Yeah. Then From there, it connected to your CRI, the runtime, container runtime, and launch your pod. That's the flow. That's the flow of your pod. So this was, I believe, this was all about Multus. Now, we also need to understand how the SRIV interfaces will be plugged into your pod and how that would work. I would really want to keep it separate, and I would really want to discuss that thing with VNF onboarding session. Why? Because it makes sense with it. I cannot explain it properly as a concept separately. It has to be part of a session where we do VNF onboarding or CNF onboarding in our case, right? And that time I need to explain different kind of interfaces and why it is needed. But you need to have this information in your head, in your mind, that um, the way of plugging or the way of plumbing that SRIB interface into Kubernetes is Multus. We are going to use Multus to do so, right? In this case, we have used Macmillan. In that case, we will use something else to do that. And I would say that's it for today, guys. So if you have any question, any comment, please let me know. And I'm sorry we are early today, but yeah,